Good morning, everyone. Dex here from A2K. And thanks for joining us for today's webinar, AEC Collection with BIM 360 Workflows. Consulting Technical Lead Chad Smith will be presenting for us. So first, we'll just go through A2K. We're all about fostering innovation through consulting and training. A2K Technologies plays a vital role in helping the infrastructure, building, mining, construction, architecture, and manufacturing industries reach their full potential by delivering complete technology solutions and support services such as education, consulting, and IT managed services. We work with visionaries to shape the future of design and in turn enable them through innovation to minimize risks, improve productivities, and achieve excellence. A2K Technologies is considered the business partner of choice and trusted advisor by vendors and clients. We partner with major software and hardware vendors to meet our clients' technology needs. We strive to exceed client expectations by understanding the challenges and delivering solutions through experience and innovation. We work with clients and companies of any size nationally and abroad. Let's get started, Chad.
Thanks, Dexter. Good morning, good afternoon, all. My name is Chad Smith. I'm a consulting technical lead here at A2K Technologies, and I help with the likes of helping customers to understand what certain products do, how they work together, help with the implementations, training, support, and so forth. So throughout the course of this year in particular, I've done quite a few webinars around various BIM 360 topics, from fairly high-level overviews to diving into some of the very specific modules and licenses of BIM 360. But one thing that we haven't covered yet is talking about some of the workflows that go into BIM 360, and most notably around the AEC Collection, which is the license, the product suite that most of you are probably subscribed to. So in this particular webinar, we've decided to have a look at a reasonably technical level, how some of these workflows can be used from the collection and with or through BIM 360, so that you can make a bit more of an informed decision as to whether some of these workflows are going to work for you if you happen to be already or maybe in the near future participating on a BIM 360 project. Now, you're probably well aware that inside an AEC collection, there is a whole range of products. Now, understandably, some of these products are there for legacy reasons. Other products are more primarily focused for your day-to-day work. And for the purpose of this presentation, we're going to focus on just a handful of the more common products that we come across that people are using from the AEC collection. That's not to say that some of these other tools don't work with BIM 360, because specifically AutoCAD and AutoCAD verticals do have some levels of integration, but we're going to focus more so on some of these BIM and 3D modeling aspect products such as Revit, Civil 3D, Infraworks, and probably more importantly, so that we can collaborate this information together in a more meaningful way, we're also going to talk and focus quite strongly towards the end on using Navisworks Manage. Now, just as a very high-level overview on these four products, because you might very well be working in one of them day to day, but you may have to work with other people that are working on some of those other tools. Civil 3D is for civil engineers. It is the civil equivalent of a building information modeling design platform, most notably for doing things like earthworks, services modeling, and so forth. Now, it has somewhat of a companion product called Infraworks, and this is for concept modeling and designing, whereby civil information, Revit information, and other types of file types can come together into an infrastructure style of concept modeling tool, whereby things like feasibility studies can be done prior to actually hitting that design documentation and construction process. Most people are familiar with Revit. That is a building information modeling software tool whereby architects and engineers alike can work together on the same design platform for buildings specifically. And Navisworks Manage is included in the AEC Collection because it is Autodesk's premier model coordination and review tool. And in more recent times, it's receiving quite a bit more development investment for working with BIM 360. Now, on the BIM 360 side, I have mentioned that we've got other webinars that we've done earlier in the year, and they were recorded. So if you want quite a bit more information about BIM 360 and these modules, you can have a look at the A2K YouTube channel and find those videos. But just quite briefly here, we're going to have a look at BIM 360 design, specifically for the Revit users to work together. Docs is a common data environment where all of these file types can come together so that users can access, link, and review this information. And a good portion of this workflow will actually tie into the BIM 360 coordinate module so that we can coordinate the different file types that are being produced from Revit, Civil 3D, Infraworks, and Navisworks. So I think it's fairly safe to say that knowing that these products exist is one thing. Knowing that there is some level of workflow through linking and other integrations, but probably in your mind at the moment is you know that they work together, but you don't know exactly how they work together, and in particular, how they can work with BIM 360. So we're now going to take a look at some technical workflows to hopefully help demystify some of this so that you can see more clearly what workflows exist, maybe which ones have value for your particular workflows and products that you use, and also maybe having a look at some of the cons as to why you may not use a particular workflow in favor of other workflows, and so forth. So the workflows that we're going to cover off, first and foremost, is just briefly making mention of the Autodesk desktop connector, because that does help us to tie together a number of these products. We're going to have a look at the Civil 3D into Revit, the Revit into Infraworks, a Revit to Revit workflow, and then we're going to jump into the BIM 360 side a little bit more deeper, having a look at how other users can integrate into the workflow as a review process, and also using BIM 360 to connect over into Navisworks and also over into Revit so that we can review and resolve design-related issues. Okay, so let's start with the Autodesk desktop connector. This is something that everybody who is using, in particular, BIM 360 should have installed. It gives you a locally accessible, syncable drive to the BIM 360 data that you have been added to those project spaces. There's a link there that you can use to go ahead and download it. We will provide this as a PDF after the presentation, or you can just simply do a Google search for the Autodesk desktop connector. It's not a requirement, but it certainly helps with having access to these files through these local drives. Now, this is all the Autodesk desktop connector does. It simply gives you a virtual drive with the accounts that you've been added into, the projects that you've got access to, and then the folders within those projects, again, which you have access to. You can access and open and save these files directly from the design tools, or you can copy files into these folders so that way they can be synced up to BIM 360 so that they can be utilized by other people such as the reviewers through the BIM 360 interface. So now that we've got our desktop connector installed, we can now start to have a look at some of these other product workflows. Let's start with a Civil to Revit. Now, Civil 3D has the ability to save your Civil 3D design files directly from Civil 3D up to the BIM 360 project space. This is as simple as having your previously local Civil 3D file opened up, and by going up to the Save As up on your menu, up on the Civil 3D button, and selecting the Save As option. Now, when we do this, and so long as that you're already logged into BIM 360 through the Civil 3D interface, you'll be able to access the BIM 360 drive, give the file a name, and then save it. That is a direct save to BIM 360 from your Civil 3D. And opening it is much the same. We'll go through the open, go to the BIM 360 space, and then open it up again. Now, why we use this particular BIM 360 drive as opposed to the local desktop connector for this particular workflow has to do with the way that BIM 360 manages the files. And you'll also notice that if browsing this file directly through the BIM 360 web interface, the file will become locked if somebody has it open on their local desktop through Civil 3D itself. As the files are saved and closed, the files will become unlocked, and this way the DWG file is protected so that users cannot be working on the same file at the same time, and therefore opening up the risk of having the information overwritten accidentally. Now, this is just to get the Civil 3D file up into the BIM 360 space so that different people can work on it at different times. But we've still got to get this information into other products such as Revit. Now, linking a Civil 3D file into Revit isn't necessarily the easiest thing to do. Because of the nature of Civil 3D with its very specific Civil 3D elements, Revit has a hard time being able to read that information natively. So this information typically has to be exported from Civil 3D into just a regular DWG file so that information can be, let's use the words, dumbed down a little bit so that Revit can actually interpret the DWG file. Now, this on its own is not a huge problem, okay? It's a valid workflow and one that is typically used when working locally with other local users and files. The file that it generates is likely to have a range of layers within it. You'll have to interpret those layers so that you can work out which layers you need in order to generate a corresponding topography item over inside of Revit. And when we do link or import that DWG file over into the Revit project space, we do get something that is reasonably neat and usable. So this image in the top right-hand corner is actually an exported Civil 3D file. It contains our elevated contours. You can see there it has existing conditions and it also has a platform that's been modeled. So this gives us some good, accurate information that we can utilize. But the problem is that even though it has that information, it's still very hard to generate an equivalent Revit version of it because of the way that the layers are structured. Understanding which layers, lines, and points that Revit is going to generate means that it might be difficult to separate certain site features, such as its platform versus the existing conditions. So in this case here, I might just want the existing conditions, and I might want the pad or the platform here as a separate Revit topography, but in this case, they are all considered one object and very hard to separate. So what Civil 3D does, with the use of BIM 360, it helps us to process the Civil 3D information in a more simplified and usable method for Revit. So instead of exporting out in Civil 3D, we instead publish the surface to BIM 360. When we go through the publishing process, we're specifically identifying which features from our Civil 3D file we would like to publish for Revit use, which in this case here is going to be the existing conditions and the platform, as we saw in those previous images. And we're now going to publish this through to BIM 360. When we do so, we end up with an additional and slightly differently named file, as we can see over here on the right-hand image. Now, I don't know technically what happens in the background through BIM 360 when it generates this, but it does so in such a way that we can now, over inside of the Revit space, use the link topography option to link in this civil 3D information. This is uniquely different to using the link CAD or the link Revit tools. Link topography is specifically for linking a civil 3D file directly from the BIM 360 space. And it opens up a dialog box to select this particular file so that we can bring it in and utilize it. Now, having said that, this is purely so that we can use an accurately modeled civil 3D file, not necessarily so that we can continue manipulating it in a Revit kind of way. Now, the advantage of doing this is the way that Revit now interprets this civil 3D file that we've just linked in. Instead of having a single link, which is very hard to then sub-select certain features, this process now actually gives us multiple individual elements that are contained within this civil 3D file. And here we can see that we've got the platform as its own unique object, which can be phased and also have its material changed. And that is separate to the existing works. But yet it still looks like a Revit file, and it can still be labeled using the contour labels tool. So it does give us civil 3D information, but it certainly in a much more intelligent manner to when we link in a DWG and have to generate a Revit topography from it. So let's now move over to a Revit to Infraworks process. Infraworks being a infrastructure or sort of urban planning tool, if you will, so that we can bring in other modeled information to build up our concept or feasibility models. The first thing to note is that Infraworks works with BIM 360 on its own. So that means we can sync our Infraworks information up into our BIM 360 project so that other Infraworks users can access it. This is as simple as opening up our Infraworks model, making sure that we're signed in through the login, and therefore, so we can then synchronize this project, this Infraworks file with the corresponding BIM 360 project folder. When we do so, we end up with an Infraworks model file that we can see here. This model file is actually quite small. It's only, in this case, 300 bytes in size, but it is essentially linking to all of the other cloud Infraworks information. Inside of Infraworks itself, if you've never seen it, this is just a screenshot of this particular sample file. We can see our Revit model placed over the top of the Infraworks information, giving us a nice visual and interactive form for that concept modeling. But even better is when we view it inside of BIM 360 itself. Here we can see inside BIM 360 utilizing Autodesk's browsing technology so that it can view models directly inside the web browser itself. I have the same model information, which in this case here has got a range of markups applied to it. It could additionally have some issues applied as well if need be. But the point is that this information is now readily available through a web browser to non-Infraworks users so that they can now contribute into the workflow and the feedback process. And we'll talk about markups and issues a little bit later on. But in terms of a Revit to Infraworks process, Infraworks being a data aggregation tool, we're going to simply add in an Autodesk Revit model as an asset. Going into our data sources from our menu, coming up to the Add button that's in the top left-hand corner of this panel, we can go ahead and select Autodesk Revit. You can see there that we additionally have the likes of DWG files, IFC files, or even database files that contain geolocated information, such as things like stormwater manholes or street lights and so forth. This is all data that we can aggregate into Infraworks. But in this case here, for the Autodesk Revit file, I'm going to go ahead and grab it directly from BIM 360 using the desktop connector. Doing so will then take that Revit model and publish it into this Infraworks space. As part of this importation process, we can configure this data source so that we can provide it a coordinate system if need be. But understandably, this is still a conceptual space, so you may not necessarily have a fully resolved or coordinated Revit model in this case, in which case you can simply place it, and then using a number of the transform gizmos for that object, we can simply move and rotate it into position. The workflow is reasonably straightforward. It's just a matter of having access to the data models through the desktop connector, hence why we need it installed. Now, onto the Revit to Revit workflow. We cover this in a little bit more detail in some of our other workflows, our other webinars and videos that we have. But just at a very high level to begin with, we should note that when using Revit on BIM 360, there are two ways that we can upload, store, and access these Revit models. Method one is using just BIM 360 docs. This is the cheapest entry level into the BIM 360 platform. It provides Revit users the ability to upload a Revit model using the likes of either the desktop connector or using the Save Cloud Model feature. But the problem here is that because we're using the BIM 360 docs licensing, this will only work with a non-work shared model. This is suitable for small teams and small project files that simply want to store their files in a cloud location so that users can access it in a sequential manner. Method two, on the other hand, utilizes the BIM 360 design licensing. And this in turn utilizes the work shared cloud model methodology, whereby work sets are activated, the model is uploaded into BIM 360, and multiple users can now access the design model at the same time. Typically, when work sharing is activated, it's for the purpose of large teams working on larger projects. Now, it should be noted that the desktop connector can be used with both of these methods in various ways. Now, for certain workflows, we do need to do them a certain way, but the desktop connector does have some connectivity to both these workflows. But there are preferred methods of uploading, and we'll cover those in just a moment. But the desktop connector for methods 1 and 2 are mainly used so that we can link files rather than opening or saving the host model themselves. There's a lot more detail on the differences between these two methods at this excellent Autodesk page, which covers it in quite a bit more detail. Now, we're going to mostly talk about the work sharing method here, but whether it's a standalone using BIM 360 docs or whether it's work shared using BIM 360 design, the initial model upload is done using the same method, which is to use the Save As Cloud Model option through the File menu. If we want a work shared model, we simply activate the work sets as we typically do. It will tell us if this was a previously uploaded model. It'll tell us that since this is going to be a cloud work shared model, you need to go through and tick on each of these options before you then hit the enable button. Now, depending on how you've uploaded this, whether it's non-work shared or work shared, this will be shown differently over here on the recents page. So if we need to open up one of those models, we would come over to our BIM 360 drive over on the left-hand side here, find the project space that we want, and then we can see whether the file is a standalone file or if it's work shared. We can then simply select those files to open them up and then work on them, either saving or synchronizing, depending on one of those two options that has been used. Now, if this is a work shared model, and hence we want a Revit to Revit process with other Revit users, then we need to consider some other functionality of the design module that helps us to work with third parties such as external consultants and so forth. Now, you might be familiar with more traditional workflows whereby you as a particular design consultant start your files. You may then zip them up, put them into an email or put them up into some kind of cloud sharing or file sharing service. You might then send an email to the recipient that you're sending this file to. The recipient may then download the file that you've shared with them. They unzip it, they review the changes, and then they incorporate the files that you've just sent them into their own workflow. So this is a fairly typical and legacy method of distributing your design files with other consultants and vice versa. BIM 360 Design, on the other hand, takes a more cloud approach to this, whereby files are stored and distributed in what they call design teams, and then distributed through the likes of what they call design packages. And this provides more of a graphical and transparent and almost timeline interface whereby all participating parties can see what information is being shared by all other participating parties. Now, digging into this a little bit more, these design teams are actually created inside the project administration space, whereby going back to this one, we could see that we've got an architecture team, we've got services, we've got a structure team, and these two are reflected over here underneath the project admin. These design teams provide a space within BIM 360 for these Revit files to be stored and assigning which users have permissions to work on those teams and thereby have access to synchronize and to share that information. Now, additionally, when we create a design team, and a newly added feature is the ability to also create what we call a coordination space with those design files. Now, I've noted this as optional because you don't need this if you're not going to follow through with some of these other workflows, but I'm going to bring it up now that we can add in a coordination space because this now ties more directly into the model coordination and the Navisworks and Revit workflows. Now, coming back to this process of how a design team works and how we use BIM 360 to distribute files to other team members, if we think about ourselves as a particular design team who is working on a number of models. So here we've got models A, B, and C. Our models are typically opened, we change it, make changes, and we synchronize any changes with the central model, which in this case will be stored on BIM 360. If we were to stop there, this could be simply considered an internal workflow so that any synchronized changes are now made available to all other internal team members who in the current environment may all be working from home. But if we instead want to extend this out to other third-party consultants, we take this a step further. We publish the information as an externally accessible package, which contains the various different models in various different packages. And then we go ahead and we share this information onto that timeline that I showed you a moment ago. In doing so, Team 1 in this case creates a package which is shared, and Team 2 can go through the process of consuming. Likewise, again, Team 1 can share the packaged information. Team 2 can choose to adopt that information if they like, but if not, then time continues on, and team 2 can then reciprocate with their files back to the other design teams. This process of packaging, sharing, and consuming replaces the traditional process of zipping files, uploading to a cloud file sharing service, and emailing the recipient. Now, with all of these files that we've uploaded into BIM 360, whether they be Revit models through BIM 360 Docs and Design, whether they be the Civil 3D models or Infraworks models, once they're stored on BIM 360, this gives visibility and access to other non-designers so that they can now participate in this workflow as well. BIM 360 at its simplest level is a common data environment so that folders can be created and files can be uploaded. Here we can see an example folder structure that has some files that have multiple versions uploaded per file, and through the use of permissions, we can control which users have access to which folders and files. The purpose of getting this information shared into BIM 360 is so that those non-designers can review the information, whether they are project managers, design managers, people out on site, even the customer themselves can have access to this information so that they can provide markups and raise issues. Issues in particular have a managed workflow wrapped behind them. That is to say that when an issue is raised, somebody needs to take responsibility for it so that it is ultimately resolved and closed out. Now, we're going to go through how issues work in this workflow process with Navisworks and Revit towards the end. But noting that issues in this case have a managed workflow, whereas the likes of markups don't. And also through a BIM 360 Docs review process, because we're uploading files many times throughout the course of the design process, it means that we can compare the different versions of those files so that we can identify what has been changed over time. Whether this is for a PDF, such as what we can see on the left-hand side, which is simply showing us the changes by way of a red and blue color coding, or whether it's a model such as a Revit model on the right-hand side, whereby we can see more intelligently how things have changed through what's been added, removed, and modified. And most of this review process can be done on a standard laptop or desktop PC web browser, or via the BIM 360 apps on both iOS and Android devices. So now that we know that we can work with our design files and that we've got review tools, let's have a look at how we then tie this together with more traditional review tools such as Navisworks, which then ultimately leads into the resolution of those issues. So when we use BIM 360 with our desktop Navisworks tool, there are two ways that we can operate. The first way is to be quite simply a BIM 360 Docs licensed user, whereby we can access this information through the likes of the desktop connector so that we can append those models and so that we can work with those models at a very local level on our desktop. Method one also suits a more free-form workflow, as you'll see in just a moment, whereby the files don't have to be too structured inside of BIM 360 and thereby giving the user the freedom as to which files they would like to use. Method two, on the other hand, utilizes the BIM 360 Coordinate license. This has a more rigid workflow to it. Files have to be stored in certain locations so that they can be brought together under the Coordinate license so that we can create consistency and standards. If we have a look at method one, with Navisworks open on our desktop, we use the desktop connector to quite simply select files, probably most notably maybe NWC files, which are the cache files that we can generate from our design authoring tools like Revit, AutoCAD, Civil 3D, and so forth. And we can store those in BIM 360 so we can then simply append them as an aggregated or federated project file in Navisworks. From here, despite using the BIM 360 located models, we can then go through and save our Navisworks project file as an NWF file and save that back up into BIM 360, again using the desktop connector. So we've got locally stored model files, we append them into Navisworks, and then we can save the NWF project file back into BIM 360 so that we can open up the NWF file in the future if we would like to continue working on this project. All other functionality of Navisworks works as you would expect. That is the clash detective, the animator, the timeliner, and so forth. It's just that you're storing the models on BIM 360 themselves. Now, I talked about flexibility of this workflow. This means that we can draw in or append any models that are stored within any of the project folders from BIM 360, so long as you as a user have permission to be able to browse those folders. Now, that workflow works. It's not bad, but the problem with method one is that it doesn't tie in directly with the issue resolution process. Now, before we get to the issue resolution process, let's have a talk about method two. Method two takes a more structured approach by reusing much of the model coordination module found inside of BIM 360. Put simply, the model coordination module of BIM 360 allows you to create, I should start over here on the right-hand side, allows you to create what's called a coordination space. This is a space that has been authorized for the uploading of design files so that they can be coordinated together. And we can have multiple coordination spaces, as you can see here. Also thinking back to what I showed you a moment ago inside the BIM 360 design space, specifically for Revit design teams, whereby a design team can now have its own coordination space, it too would show up underneath this dropdown. Once we start browsing into a coordination space, we can start viewing or seeing all of the models that are available, and we can start selecting them so that we can view them together. This is kind of like the BIM 360 equivalent of appending models such as in Navisworks. And keep that correlation in mind, because that is exactly what it is when we get back to the Navisworks space. You can also see inside the model coordination space that we have a space to create what we call views. These are combinations of model files that have been saved as views for future for recalling at a later stage. Now, inside of BIM 360 model coordination, quite simply, this is what it looks like. It's so that we can federate models together and find clashes. That same process works directly inside of Navisworks. So instead of using the typical Navisworks append tool, we instead use the coordination tab up the top here, which has been installed by using this additional apps add-on that you can find on the Autodesk App Store for Navisworks. Doing so means that we can now open the models directly from BIM 360. We do this using the same coordination spaces, and we can select the individual files that we would like to open up. Just taking a moment here just to explain that the models that we see in this list don't exactly reflect the files that are within that same folder and coordination space. you'll notice that there are multiple MEP models that have different coordination, I'm going to call them views, found within this file. And this has more to do with the way that those Revit models are actually set up in the first place. It's just that the MEP model contains some predefined 3D views, and those 3D views instead are listed within the coordination space. So now that we have the ability to append or to open up our BIM 360 models, regardless of whether they're Revit, DWG files, or IFC, we can now go through the issue resolution workflow. Let's start this workflow inside of Navisworks, because as we just saw, we can actually open those files up directly from the BIM 360 space. Now, instead of appending those individual views or files, we can instead append a view. Remembering back inside the BIM 360 model coordination space, we could save views of different combinations of files. Well, when we go through the Navisworks opening option, we now have that same tab so that we can consistently open up, in this case, the same mechanical and structural information. When this comes into Navisworks, we can see the files in the selection tree. They've obviously been aggregated, and within this aggregated model, we can now start seeing, by way of these little orange pins, where the issues have previously been raised. The Issues tab, which is open here on the right-hand side, is now drawing in issues that have been raised over inside of BIM 360. It's important to note that the issues that it's pulling through now are only those issues that were attached to these opened models. So we're getting some context on the issues so that we don't get the full list, we're getting a filtered version of that list instead. I said before that when we're using the BIM 360 with Navisworks method 1, the issues resolution workflow is not supported. And that's made quite clear inside the BIM 360 issues panel inside of Navisworks if you were to try to use method 1. Method 2, on the other hand, is the preferred method because it ties in closely with the existing BIM 360 model coordination module and model coordination workspaces. And this process is much the same for Revit as well. So without diving too deeply into the Revit side, we open up our work in progress Revit model. We're then able to load a selection of issues that we would like to view, which in this case, we can pull from our coordination space. And those issues are overlaid on top of the model, very similar to the Navisworks, so that we can review and close them out if they've been resolved. So the point here is that with these workflows now, with BIM 360 built into it, we not only have a space where we can store our design files, but we can link between these products in various different ways, depending on what that workflow is from one product to the next. But it now ties into that pre-construction and construction process where either design or construction issues are raised. And depending on the design tool, most notably Navisworks, well, that's not a design tool, but most notably Revit, and by extension Navisworks as well, those issues that are now raised in that pre-construction and construction stage can now be viewed and resolved at the design level. So let's just take a brief look at some of these workflows in a little bit of a hands-on approach. Here's BIM 360 docs, and to begin with, we can see that I've got my work in progress folder. Here's my different design teams, including the infrastructure or maybe the civil team, in which case here is the Infraworks model. We can open it up. This is typically a fairly large file when viewed inside of Navisworks, but under BIM 360 itself, it's actually nice and lightweight now. We can orbit around it, didn't take long to load, and we can get this concept level information so that reviewers can now view things like the markups that they can quickly select and move through in order to be able to review the information. Like so. If we need to add on another markup, I'll just exit out of that markup view. If we need to add an extra markup into this, maybe we might want to put some kind of viewing deck over this little lake area here. We can use the markup tools over on the right-hand side. I might maybe let's use the freehand tool here. I'm just going to draw in and say, put that in, and let's put the text in. Let's put a viewing deck. Let's just change the properties. We'll give that an opacity. There we go, like so. And we can go ahead and save that markup over the top of my Infraworks. It gets added into the markups list on the left. It has details about who raised it and the version of the document that it was placed over the top of. Now, this file here doesn't have any issues attached to it, but I could just as easily use the issues tool. Let me jump out and let me now go over into my coordination space, which you saw in a number of those screenshots from the slide deck. And let's open up, let's see here, let's open up the MEP model. This MEP model, we can immediately see it has some previous issues that have been raised. So let's go ahead and select it. And again, using the Autodesk browser technology, it's going to load this model in. Should be reasonably quick. They are lightweight versions of the equivalent Revit file, and we can immediately see our exportable views, similar to, again, to what we saw in those screenshots in the presentation. In this case here, though, this model has issues, and those issues we can select and identify in which one of those views and which elements that issue is referring to. These issues, as I said before, are managed. They provide data, they provide attachments if they're there, a full activities list, and the ability to be answered and ultimately closed out. Now, in this case here, some of these issues, not this one here, but if I select maybe this one, this issue, let's get rid of that highlighting, there we go. This issue has been derived from the model coordination process. The viewing of this file does not include the secondary file, which happens to be the structural model, because we're not viewing it within the model coordination space. However, over on the attachments tab, it'll still provide me a screenshot showing me the full context. Instead of viewing this through the docs interface, if I instead view it through the model coordination interface, we can again see those different files, such as the mechanical or the structural, that we can view, or alternatively using one of those quick views so that we can select it. This will in real time aggregate those two models together, and so therefore we can then view the clashes and any previously raised issues. This has clashes already, including those issues. Let's give that a moment to load. And if we select the same issue that we were looking at a moment ago over inside the doc space, we can now view it in with. Again, this is another issue. If instead we want to do this back over inside of maybe Navisworks, or here it is already opened up, although this was done using the Open Models button here. Let's give this a moment to load up. Okay, there we go. So we've chosen our account, the project. Here are those exact same models from those exact same coordination spaces and the views, which in this case, the mechanical and structure has been opened. Here are those markers so that we can identify there was an issue maybe here. through the BIM 360, identify the details of that. So again, so we can go ahead and review it and close it out. Let's say in this case here, maybe not that one. Let's have a look at, actually, let's do this one here. So maybe in this case here, this issue is now resolved through the model review. We can simply use the status option and close this out, put a reason in why it's closed, and update it. If we now jump back over to our BIM 360 space, and if we do a refresh on the browser, that was 117, yes it was, just double checking. We can now see that that issue has been closed out. And if we wanted to, we could go ahead and, where's the status there? We could turn on those that closed attribute, and we can see there that that issue has now been resolved. But we don't, I guess we could resolve it inside of Navisworks, but typically when we're making resolutions of this type, it's typically done over inside the authoring tool itself. So the last step here is just to have a look at it inside of Revit. Now, unfortunately, this is only available inside of Revit. Some of those other design or authoring tools that I've covered off today, I don't have this kind of functionality at the moment. It's not to say that Autodesk are working on it, but certainly for Revit, in its beta status, there is an additional add-in that can be installed. Now, here we can see the services model. This is all services, but it's not doing a clear job of showing me where those issues are found. And that's because when these issues were raised, they were done so on a different view. And we can see here, this was the coordination and, the mechanical coordination view within this Revit model, which when these issues now refresh, we can now see these little indicator balls over the top of where those issues are found. And in fact, when we now click those issues in the panel on the right-hand side, they then activate and show us where they are over inside the model. Again, we can rectify the issue and then close it out through the status. Okay, we're almost done with time. If you have any questions, I welcome you to submit them through the Q&A panel in the Zoom interface. Just as we finish off here, I'm just going to go back to my presentation. Just give me a sec, just open that back up. Okay, so if you've got any questions, please do put them into the Q&A panel inside of the Zoom interface. Just while you're thinking of any questions and typing them in, we are routinely doing events such as this, so you can go to the A2K Technologies website /events and browse what's coming up. And secondly, just go to the next, where it is there. Okay, secondly, if you would like to follow up with myself on any of these topics, particularly around the products that we used, or if you're interested in maybe getting some training for your team and so forth, I invite you to take up a 30-minute follow-up meeting at the following link. I've made my calendar available for the next few days leading into mid next week, and I'd be happy to have a chat with you about any of your needs regarding BIM 360 or any of those design products. Okay, so we've got a couple of questions coming into the Q&A panel here now. The first one is, how does iConstruct interface with BIM 360 functionality? The answer there would be, and I'll just probably qualify first, is that I'm not an iConstruct user, although I'm well aware as to what it is and that it is a Navisworks add-in. In this case here, you would need to be working inside of Navisworks. So you would need to be able to draw your models in from that BIM 360 space, so you can then do some iConstruct, we'll use some of the iConstruct functionality on your models. Now, I can only assume that when you do use the iConstruct module, that any information that's then stored within the Navisworks project, if you were to save that NWF file back into BIM 360 using the desktop connector, I can only assume that that information is going to be saved with it. If iConstruct has any direct integration with BIM 360, I'm not aware of that, and you may have to ask them. But certainly, if working with the Navisworks file, that information should be saved into BIM 360 with the NWF file. There's another question there. Can those issue spheres within Revit be made to be transparent so you're able to see the issue the sphere is showing? Now, that is a good question. Let me jump over here. Let's have a look at this. This integration has only been around for a couple of weeks, and I'll be honest, I haven't dug that deep into some of the nuances. It looks like I am having just some issues with selecting the sphere, so I don't quite know at the moment how they're defined within this space and why I can't select them. And we'll just have a quick look just while we're at it. Let's have a quick look inside the visibility graphic overrides. I thought they may have been on the generic models category. It doesn't look like that may be the case. There are certainly no other buttons, as we can see up on the ribbon interface, that helps us to control the visibility. So at this stage, my answer would be, I'm not entirely sure. Okay, so that were the only two questions that were in the Q&A panel. Let's round out the session. Again, if you want to follow up, there's a link here. We'll put this into a follow-up thank you email along with the presentation itself. But we're getting close to the hour, so thank you very much for attending. This was a slightly more technical presentation, so I'm hoping that helps you with working out whether some of these workflows are valid for some of your project requirements. Afternoon, everybody, and have a great day.